And we are now recording. Okay. All right. So on this 5, 6, multiples of 5, let's look down here. This first one, we talked about this a little bit yesterday. Number 5, but as an example, I'm going to do number 7. So additive inverse. We talked about what additive inverse was a little bit yesterday. Somebody tell me what's the additive inverse of 7? Negative 7. The inverse property of addition is when you add two things together and it equals what? 0. So an example, 7 plus negative 7 equals 0. You might put that there. So the additive inverse of negative 7 would, the additive inverse, which number 7 here, which is negative 6i, would be what? 6i. So now you will do 5 and 10, find the additive inverses there. Now let's move down here. Let's talk a little bit about absolute value. We discussed yesterday that on complex numbers have a complex number coordinate plane. If you missed this yesterday, there is this right here is which axis? The X is what though on a complex for you guys over here? Not imaginary, real. So a complex number can have so much real parts and then so much imaginary parts. And a complex number could travel so much on the real and then so much up and down, and we're gonna want to know the distance from the origin. That would be its absolute value. So let's look here. You would be doing number 15. So let's do instead of 15, let's do 16. 16 has 5 real parts. On a complex number, Jaden and Josh, y'all missed this yesterday. The first part, 5, that's the real part of the number. The negative 2i is the imaginary part of the number. They call it complex because it has both parts. So 5 negative 2i, would go 5 out on the real. I'm just going to say it's right there. And 2i down. So imaginary parts are 2 down. So it's somewhere in here. And we want to know how far is that? How far is it from the origin? So we use the distance formula or Pythagorean theorem. So we would say, on this one right here, we would say 5 squared plus 2 squared, and then take the square root of it. So that would be the square root of 25 plus 4, yes, the square root of 29. Now, 29 is a number that is prime, isn't that right? 29 is prime. And so 29 does not have a factor. Now, remember yesterday at the beginning of the day when we were simplifying these? Y'all remember that? We would take factors out that had square roots, and they would come out of the radical symbol. So 29 doesn't have anything that has a square root. So the what number was it? 16. So 16, the answer, the absolute value is square root of 29. That's how I'd leave it. And here's one, has 9 and 4, right? That'd be 9 plus 4 is 13. Wouldn't that be that? Yeah. Trying to find one that would have a 12 would have 25 and 144. Okay, so here's one. If you look at 12, you would have the square root of 25 plus 144, square root of 169. This one would be 13. That would simplify. Sometimes, though, what I would like to point out is sometimes you'll get a number like this, the square root of 50. If you have the square root of 50, what did we learn yesterday? How would I write this? How would I simplify the square root of 50? Not 10 and 2, because neither 10 nor 2 have a square root. It's 5 squared to 2, because what is 5 the square root of? 5. You think of 50 as 25 times 2. You want to think of a factor that has a square root. Remember us discussing this yesterday? And since 25 has a square root, it comes out as a 5, and you leave the 2 in. So sometimes you can simplify, like a number like 50. Sometimes nothing has a square root. We just leave it as Square root of 29. 169 had a square root, it came out as 13. So there's every variation. It has a perfect square root, a factor of it has a square root, or no, it's prime or it doesn't have any factors with a square root. Possibilities of simplifying radicals there. Y'all follow that okay? So absolute value, you're going to use this imaginary or real and imaginary coordinate plane to find the distance of any complex number from the origin. Let's go down here to, here we go, simplify an expression. What's that? So here is an example. Here, let's just do number 26. Does 40 have any factor with a square root? Don't say 8 times 5, because neither 8 nor 5 have a square root. I want a factor of 40 that has a square root. 4 times what? So I can think of 40 as 4 times 10. Which one of those has a square root? 4. What would its square root be? So you would have a 2 square roots of what? The one number that didn't have a square root. See how that turns into that? And 10 doesn't have a factor. 10's only factors are 10 and 1 and 5 and 2. None of those have a square root. So that's how you would simplify something like 26. Let's see, the first one you're going to do is 30. 30 is just subtracting, this is complex number minus another complex number. When you do this, well, that's the exact, that's kind of interesting. Someone tell me what the answer to that is. Thank you. 3 minus 3, you subtract corresponding parts. 2 imaginary parts, subtract other 2 imaginary parts. Let's just all answer that one as 0. And then I do want to show you the process. This is where you have to think a little bit. Number 35. So 34 is very similar to it. I'm going to do 34 right here on a piece of paper with you as an example. And then you guys can do 35 or try 35. So 34 is 1 plus 5i multiplied 6 minus 3i. So here is 34. Let's look at this. Now, when we left yesterday, we were talking about how we covered a lot yesterday, didn't we? And we walked away from it, and we came back today. This is day 2 of looking at some stuff for the very first time. This isn't like your normal math. A lot of stuff you have in math, you have built on repeatedly over several years of math, all the way from your 5th grade year until now. As an Algebra 2 student, for some of us, this is the first time we're dealing with these kind of things. So it's natural that on day 2, we're still really learning it, right? So if we were multiplying, this is a complex number. It has a real part and an imaginary part. Multiply it to another complex number, real and imaginary. What is the acronym we use to multiply the two? We said it yesterday. FOIL. I like how Josh, being here yesterday, remembers these things. I'm joking. For those of y'all watching the video, Josh was not here yesterday, but he remembered FOIL. This is how we multiply binomials, and we can still apply it here. It just gets a little bit of a different answer. Work through it with me. What's first going to give us? 1 times 6. What's O going to give us? 1 times negative 3i. Anything times 1 is itself, right? Negative 3i. What's enter going to give us? 6 times 5i. 30i. Now you might notice that 6 is a real number. That is an imaginary number. And that is an imaginary number. These two will end up going together because they're both imaginary. Then the last, the L, gives us something a little bit different to look at. It'd be minus 15 what? I squared, right? And we learned yesterday, if you don't remember this, I squared equals negative 1. So we see negative 15i squared as negative 15 with a negative 1, which is, like you said, Josh, yes, that is just 15. So when you answer it, you put your real parts in the front, your imaginary parts second, What is the real parts? How many real parts do we have? You got this one and you got this one. I mean, add them up. You got 6 and you got 15. 21. That's negative, negative, positive 15. Minus 15i squared becomes positive 15. So 6 and 15, that's 21. And then we got negative 3i and a positive 30i. That leaves us how much? Positive 27i. That's how you take two complex numbers and multiply them. You use this FOIL process, and you end up with a complex answer. That's it again, right there. So you'll have some just like that. If you look here, 35 is a problem like that where you're going to FOIL. 40 is a subtraction, subtracting just corresponding parts. Let's just do 40 together. Somebody tell me your answer. What would the real part be? Negative 1 is the real part. That's 3 minus 4. What is the imaginary part? 6i. That is from 3i minus a negative 3i becomes 6i. Y'all go with that? And we scroll down here. 45 is another multiply. I'll let you do that. 50 is another add. I'll let you do that. 55 is another multiply. I'll let you do that. 60 is another subtract. You can do that. 65 is another add. I'll let you do that. All right, let's go down here. Sorry, I'm so stupid sometimes. Now we have some solving. You can solve by factoring. You can solve by the two ways you know right now are by factoring or by putting it into a calculator, right? So let's look at it on the calculator. A lot of people like the calculator approach. We have 2x, we're going to, 70, we're going to do 69 right here beside it. All right, so here on the calculator, I'm going to, there's a way on this that I can find roots. If I'm asked to solve a quadratic, I'm asked to find its solutions, its answers, its roots, its zeros. Remember all those synonyms? So what button do I hit over here? When I get in the menu, anybody know where I can find a way to solve this? In the algebra area? Yes. Numerical solve will do it? Does it do it? That's how I was doing the other day. I don't know if numerical solve will do it. I don't know. Let's try polytools, because that is a polynomial. And that says find roots. This says real roots or complex roots. For some reason, I'm assuming we're going to get some complex roots, don't y'all? So let's just go to complex roots. All right. So we type it in. Let's see if we type it in. 5x squared plus 500 equals 0. What do you guess? What else do you guess I need to do? I guarantee I'll get an error if I enter there. There's probably something I need to do. That's right. Very good. I need to put a comma. Say I'm solving for x. And use a polynomial in expanded form in one variable. Oh, you know what I did? No, I didn't. Did all y'all get an error as well? Well, let's go back and adjust it. I don't think, I think I have to put the x. Yeah. Let me go back to menu, algebra, find roots. I'm going to try this. Still 2. Tab down, I'm going to say complex there. That's a little easier. Now it'll work. It should work. What is the first one, A to 1 is what? 5. The A1 is numbered by your quadratic term is a 5. What is by the linear term? Can y'all see what's by the linear term where my finger is? Nope. Zero. There, what I'm trying to get you to recognize is there's not a linear term, is there? Yeah. So we went quadratic term, then constant. So this is 500. 500. Enter. Enter. Oh, you see what I did? You don't put the equal sign there. You just put the 5x squared plus 500 solved for x. Same thing. There they are. They are complex. Negative. Looks like negative 10i and positive 10i. And that's what I'm seeing. Negative 10i and positive 10i. Now, I want to show you how you could have got that on pencil and paper, just so you can see it together. Please write this down. Stephen, where are you writing that? You have the paper there? Oh, yeah. All right, so, hey, write this with me. We're going to write number 69 down. I want to show you how this is very doable. So 5x squared plus 500 equals 0. We have said before, if you factor it, if you can factor it, you could solve it that way. So this thing does factor. I could take a 5 out of both, and that's all it will do. So if I just take the 5 out, I'll get x squared plus 100 equals 0, right? And then what do you do with those factors? You set them both equal 0. So 5 equals 0 is nothing. We just say 5 does not equal 0. X squared plus 100 equals 0. Then we solve. Got our factor set equals 0, which is pretty much, we could have started there with, if we just factor the 5 out to make the number easier. This would give me x squared equals what? Subtract the 100. Negative 100. And before you started working with imaginary numbers, you would have had to stop right there, because how do you find x when it's x squared? Anybody know this? How do you make it from x squared to x? Square root, both sides. And this would have stopped you up until now, because you go, wait a minute, I can't take the square root of a negative. I want to solve both sides I want to solve this thing by taking the square root of both sides to make x equals. I can't do that. You would say there's not a solution. There's not a square root of a negative 100. But now we know, well, what is the square root of 100? 10. And because the answer right there is negative, because the radicand is negative, it's 10 what? I. Remember, with the square root of a negative is always I. And this is the positive and negative 10i is what you would have right there. And that is what you can get through your calculator method, negative 10i and positive 10i. So 70 would be handled, you could handle 70 just the same. And 75, you can put it in your calculator and do the same thing there as well. It'll give you the complex roots.